resistors. Generally, we'll be having two types of combinations again. One is called as series combination and another one is called as parallel combination. We'll be discussing about that. So first, what is meant by combination of resistors? When two or more resistors are combined, or you can call it as joined together to form a network. That's what we'll be calling it as the combination of resistors. So let's take two resistors are there. Let's take this is R1 and this one is R2. So now what I'm going to do means I'm going to combine this resistor. How? In a form of end to end like this. If you are connecting in a form of end to end means then I can say that it's in a form of a series combination. The given network is in a form of series combination. When the two resistors are connected to a common point like this means then we can say that the given combination is in a form of parallel. That means if the resistors are connected to a common point, then the combination is called as parallel. And in 1 mark, I saw a question which is twisted. A piece of wire is cut into 3 equal parts and twisted with each other. If it is twisted means whether it will comes under the series combination or it will comes under the parallel. This is what twisted represent. The given combination is in a form of parallel. Next. So generally, we are having the two basic types of combinations are there. One is called as series combination, another one is called as parallel combination. So first, what is meant by series combination? Already learned the basic thing in the part 2 or 3, I think. So whenever two or more resistors are connected in a form of end to end. So we need to remember a condition in series combination. The magnitude of current, magnitude in the sense the numerical value, that means a number, is going to remain the same. It's going to remain the same. Whereas the potential difference will vary from one resistor to the another resistor. Why? Because the potential difference is varying means it's connected in different points or different ends. Due to this, the potential difference will vary from one resistor to the another resistor. Next, we'll derive the expression for combination of resistors in cell. So look at the circuit diagram. Whether the given resistors are connected in series or parallel, it's in a form of a series. Why? Because the resistors are connected in a form of end to end. The resistors are connected in a form of end to. So we can say that the net potential difference. What is the meaning of the word net potential difference? Total. The total potential difference which is created across the ends of network is equal to the sum of potential difference which is created across the ends of each resistor, across the ends of each resistor. Then we can write it as V is equal to, what is the meaning of the word sum? Addition. V is equal to V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. Let's take this equation number 1. So now, from Ohm's law. So what is the Ohm's law formula? Ohm's law formula we all know. V is equal to I into R. Let's take this equation number 2. So now what we are going to do means we are going to substitute. We are going to substitute equation number 2 in equation number 1. So what is equation number 2? V is equal to I into R. So these values we are going to substitute in the places of V. Then how I can write IR is equal to I1 R1 plus I2 R2 plus I3 R3. Clear? Good. In the starting itself is said in series combination the magnitude of current is going to remain the same. Since we doesn't know the magnitude, we can assume it as I. So in the places of I1, I2, I3, we are going to substitute as I means. Then the formula rearrange it as IR is equal to IR1 plus IR2 plus IR3. Clear? In these three, what is there on the right hand side, which is common? I alone is common. Take that alone outside. Remaining what will be there? R1 plus R2 plus R3. So I will get cancelled each other. Remaining what will be there? R is equal to R1 plus R2 plus R3. So R is equal to R1 plus R2 plus R3. So there are three resistors. Suppose if I am having two resistor alone means this one alone you can reduce. If you are reducing like this means what will be the final formula? Rs is equal to R1 plus R2. If 4 other means you can add one more. What will be the final formula? Rs is equal to R1 plus R2 plus R3 plus R4. So in the general format, if you are going to write means the net resistance in series or the equivalent resistance will be equal to R1 plus R2 plus R3. R equivalent is equal to R1 plus R2 plus R3 plus up to infinity. How many resistors are there? We can add. So based upon this condition, we are going to prove this one. Let's take the value of R1 is equal to 2 ohm and the value of R2 is equal to 4 ohm and value of R3 is equal to 6 ohm. We'll try to calculate the net resistance or equivalent resistance. So what is the formula? Rs equal to R1 plus R2 plus R3. What is the value of R1? 2 plus 4 plus 6. If you're adding all these three numbers, you'll be getting as 12 ohm. You'll be getting as 12 ohm. The net resistance in series combination will be greater than the resistance of each resistor. The net resistance will be greater than the resistance of each resistor. What is the value of R1? 2. R equivalent 12. So 12 is greater than 2. Like that 12 is greater than 4. 12 is greater than 6. Then you can say the net resistance is greater than R1, R2, R3. So in this given combination, which one is the maximum? 6 is the maximum. That means R3. So you can say that the equivalent resistance will be greater than the maximum individual resistance of resistor. Always the net resistance will be greater than the maximum. For example, you are taking the values like this. R1 is equal to 0.1 ohm, R2 is equal to 0.5 ohm, and R3 is equal to 0.2 ohm. In these given three, which one is the maximum? R2 is the maximum. That means the net resistance will be greater than the maximum individual resistance of resistor. Since the net resistance is high, the amount of current which is passing through the circuit will get decreased. Amount of current which is passing through the circuit in series combination will get decreased. Why? Because as per the Ohm's law, we know resistance is inversely proportional to the current. And then one more condition, you can say that in series combination, the net resistance will be I. And in our question paper, they'll be using the term called as IS. This word IS represents the given combination is in a form of a series. Next slide. That relations only it is given. Now, the first topic you learned what happens if voltmeter is connected in series. Reason it will impact. Why it's going to reduce means voltmeter is a type of a high resistance device. If it is connected in series, the resistance will increase further and the current flow will get decrease. Next, a question is in. Look at the circuit diagram. Is it series or a parallel combination? Series. So what is series formula? RS equals to R1 R2. So R is equal to what is the value of R1? 20 plus R2 4. So R is equal to 20 plus 24. Sorry, 20 plus 4 24 4. So what is going to be the net resistance of total resistance or net resistance or equivalent resistance? All the three meaning are same. So what is the net resistance over here? 24 4. Second, they're asking us to calculate current. So what is the formula to calculate current? I is equal to V by R. Check what is the value of potential difference given in the question. 6 volt. So the value is given as 6 volt. So now substitute in the place of V, I is equal to 6 by 24. 1 6 are 4 6 are. So 1 by 4 is going to be 0.25. How much amount of current is passing through the circuit? 0.25. Suppose for example, in the question they are saying that an amount of 0.25 ampere of current is passing through the conductor means how much amount of current will pass through the electric bulb? 3. Reason in series combination, the flow of current will remain the same. Now, third, we need to calculate the potential difference. Whether the potential difference will remain same or else it will vary. Vary. We'll calculate the individual potential difference. In order to calculate the individual potential difference, we are going to use a formula as V is equal to I into R1. So, what is the value of I? 0.25 into what is the value of R1 is here? 20. 0.25 into 20, it will be equal to 5 volt. Like that. V2 is equal to I into R2. So, what is the value of V2? 0.25 into 4. So, that will be equal to 1. So, after this, we can stop. So, if we need to check the answer, what we found is it correct or not, we can just add V1 and V2. While starting the derivation itself is said that net potential difference will be equal to the sum of potential difference which is created across the ends of the each resistor. So V is equal to what is the value of V1? It is 5 plus what is the value of V2? Sorry, 1. So V is equal to 5 plus 1 6 volt. So this value and this value need to be same. If it is same means the answer what we found in all the places is going to be clear. Next. Draw a schematic diagram of a circuit consisting of a battery of 3 cells. Totally how many cells are there? 3 cells. And what is the potential difference of each cell? 2 volt. Then the net potential difference is going to be 3 into 2. 3 to that 6 volt. Plus minus. Minus need to be connected to the positive. And then a 5 ohm, an 8 ohm and a 12 ohm resistor and a plug-in are connected in series. Series means we all know it's going to be in the form of a end to end. So R1, R2, R3 along with that a plug-in. Yeah. So this is R1 and what is the value of R1? 5 ohm and R2 8 ohm, R3 12. And after this, mention the direction of current. Always we need to give only the conventional current. Next, the second question what we'll be saying is, we need to redraw the same question number 1. So the judge is going to redraw again. Now, here's the question again. Putting an ammeter. So where you need to connect the ammeter? Is it in series or parallel? Series. So here in this place, I'm going to connect the ammeter. Can I connect the ammeter in this place? No work. Here. 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 In all the places we can connect the ammeter. That is your wish. Clear? But it need to be in a form of a end to end. And then ammeter to measure the current through the resistor and a voltmeter to measure the potential difference across the 12 ohm alone they're asking. In these three, which one is the 12 ohm? Either R1 or R2 or R3. R3 is the 12 ohm. What is the value of R1? 5 ohm, R2 8 ohm, and R3 12 ohm. So then how we need to connect means across the ends of the 12 ohm resistor, we need to connect the voltmeter. And here, plus is the, so this end is going to be plus, minus, minus. So this end is minus and this end is going to be plus. So what I think they're asking us to calculate? Find the readings in the ammeter and voltmeter. For what purpose are you using ammeter? To measure the current. And voltmeter to measure the potential. If we need to find the current means, first we need to calculate the resistance. So what is the formula here? Rs equal to R1 plus R2 plus R3. So R is equal to, what will be the value of R1? 5 plus 8 plus 12. If we're adding all the numbers, we'll be getting the net resistance is going to be 25. So what is the net resistance? 25. Now, by using this value, let's calculate the current. So, I is equal to V by R. So, what is the value of V? 6 volts. Already derived that one. So, it's 6 by 25. 6 by 25. So, divide these two numbers. 6 divided by 25. Add a 0. Keep a decimal place. 2 50s are. So, 2 25s are 15. Again, 10. Add a 0. 4 25s are 100. So what is the final answer? I is equal to 0.24 ampere. So in this conductor, 0.24 ampere of current is passing means in this conductor how much amount of current will pass? 0.8. The R2 same amount of current will pass. Now we need to calculate the potential difference. V1 is equal to I into R1. Like that V2 is equal to I into R2. V3 is equal to I into R3. What is the value of I? 0.24 into, what is the value of R1? 5. 0.24 into 5. Like that. 0.24. Sorry, 24. 1.2. 1.2 volt. So 0.24 into 8. Multiply these two numbers and say the answer. So now 0.24 into 12. Which one? 1.8. Okay, this 68 or 88? 88. 2.88. So if you want, you can check this answer also. So 1.20, 1.92, 2.88. So 10, remainder 1, 9, 10, 18, 20, remainder 2, 2, 3, 4, 5, 6. So 6 1. So this answer and this answer, what is it? Both are correct. So one boy said that the answer is 2.68. We'll try like that also. 1.20, 1.92, 2.68. So if you simplify 0, 1, 10, 16, 17, 18. Balance 1, 2, 3, 4, 5. So 5.80. Is it correct or wrong? Wrong. Yeah. Why? Because this one is 5.8 and that is 6. Both are not equal. Since it is not equal, answer also it is wrong. So in one place we made error. So what error we made over here? We gave it as 2.8. That one you need to check and we need to correct into 2.88. Do the multiplication properly. Next. A battery of 9 volt is connected in series with the resistors of 0.2, 0.3, 0.4, 0.6 and 12 ohm. How it is connected? All are connected in a form of a series. Series means we know it is going to be in a form of N to N. Totally how many resistors are there? 5 resistors. R1, R2, R3, R4, R5. What is the value of R1? 0.2, 0.34, 0.44, 0.54, 12. So in the question, what they're asking, how much current will flow through the 12 ohm resistor? So in this resistor, how much current they will be asking? Suppose in this resistor, let's take X ampere of current is passing. What about the current in the remaining resistors? Whether it will change or else it will remain same? Remain same. So in order to find this value, first I need to know what is the net resistance. In order to calculate the net resistance, we can use the formula R is equal to R1 plus R2 plus R3 plus R4 plus R5. So what is the value of R1? 0.2 plus 0.3 plus 0.4 plus 0.5 plus 1, sorry, 12. And 12 or 13 point? 13.4. Now we need to calculate the current. So what is the formula? I is equal to V by R. What is the value of V? It is given in the question? 9. So 9 divided by 13.4. We'll divide these two numbers. So 9 divided by 13.4, that will be equal to 0.671 ampere. Or you can write it as I is equal to 0.67 ampere. I is equal to 0.67 ampere. Wait, image. Yeah, so what is the value of current over here? I is equal to 0.67. So across the 12, in the 12 ohm resistor, we got how much current is passing? 0.67. How much current will pass through the 2 ohm resistor? 3, 0.4, 0.5, 0.6. Yeah. Next. Second part we are having about the combination of resistors in the form of parallel. That means when two or more resistors are connected to a common point, then you can say that the given combination of form of parallel. In parallel combination, the potential difference will remain the same, whereas the magnitude of current will vary from one resistor to the resistor. Series, which one remains same? Current remains same, and which one varies? In parallel, which one remains same? Which one is varying? Yeah. If you are having any confusion, remember like this. Series, parallel. Here, I is there. What is the I stands for? Current. That means in series, current is going to remain the same. In parallel, the letter word starts with the letter P. So here, the potential difference also starts with the letter P. Then we can say that in parallel, potential difference is going to remain the same. At least remember like this. Clear? Now, there are the expression for a net resistance in parallel combination. So we can say that the net current will be equal to sum of current passing through each resistor. In the first derivation we gave, right, sentence for a series. Sentence will rearrange. The net potential difference, no need of this word. The net potential difference is equal to the sum of potential difference which is created across the ends of each resistor. Same as it is, the net current will be equal to the sum of current passing through each resistor. Clear? Net current means total current. That means I is equal to totally how many resistors are there? Three resistors. Then I can write it as I is equal to sum means we all know it is addition. I is equal to I1 plus I2 plus I3. Now let's take this equation number 1 again from Ohm's law. What is Ohm's law formula? V is equal to I into R. Here we need I or V? I. So based upon that, if I'm going to rearrange, I can rearrange it. I is equal to V I R. Let's take this equation number 2. So now what you are going to do means we are going to substitute equation number 2 in equation number 1. What is equation number 2? I equals to V by R. This V by R we are going to substitute in all the place of I. V by R is equal to V1 by R1 plus V2 by R2 plus 3 by R. So by using these formulas, we can calculate the individual current. I1 is equal to V1 by R1, I2 is equal to V2 by R2, I3 is equal to V3 by R2. So in parallel, the potential difference will remain same, but we doesn't know the magnitude, so you can write it as V1, V2, V3, V. Then I can rearrange it as V by R is equal to V by R1 plus V by R2 plus V by. So in right hand side term, V is common, so take the total on outside. So V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So V cancel. Remaining what will be there? 1 by R3. What type of combination? Parallel. 1 by R3 is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we are writing in the format of 1 by. 1 by means it is nothing but called as the reciprocal. So in the question they will be asking like this. Derive an expression for the reciprocal of net resistance is equal to the sum of reciprocal of resistance of each resistor. That means which method you need to derive, either series or parallel. You need to derive. Let's take the same values over here. R1 is equal to 5 ohm, R2 is equal to 10 ohm, and R3 is equal to 30. So what are three values you took over here? R1 is equal to 5 ohm, R2 is equal to 10 ohm, and R3 is equal to 30. So what is the formula to calculate net resistance in parallel? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp is equal to 1 by, what is the value of R1? 5 plus the 1 by 10 plus 1 by 30. So 1 by Rp is equal to, take LCM of all the three numbers or make the denominator common. Into 6, into 6, into 3, into 3, into 1, into 1. 1 into 6, 6 plus 8 plus 1 divided by 30. So 1 by Rp is equal to 10 by 30. Take the reciprocal. Rp is equal to 30 by 10. 0, 0 cancel. Remaining what will be then? Rp is equal to 3 ohm. Most of the students will simplify here itself and then they'll divide and then they'll be giving the answer as 0.33 ohm. Is it right or wrong? Wrong. So we need to take the reciprocal and then we need to simplify because we need Rp, we don't want 1 by Rp. Yeah. So if you're observing whether the net resistance in parallel is it high or low, is going to be low. So the other one word what they'll be using is lowest. Lowest resistance means it represents the given combination as parallel. So in parallel combination, the net resistance will be lesser than the resistance of each resistor. What is the value of R1 we choose? 5. But what is the net resistance we got? 3. This 3 is lesser than 5. 3 is lesser than 10. 3 is lesser than 30. That too, it will be lesser than the least individual resistance of resistor. In this given combination, which one is the least? 5. The net resistance will be lesser than 5. For example, we are taking one more value. R1 is equal to 1 ohm and R2 is equal to 3 ohm. Let's take the option as A is equal to 1 ohm, B is equal to 0.3 ohm, C is equal to 3 ohm, and D is equal to 4 ohm. Yeah. So what will be the answer? 0.3. Why? Because in all the 4 options, these numbers are greater than or equal to the least. In this, which one is the least? 1 is the least. So we know in parallel combination, the net resistance will be lesser than the least. That means it need to be lesser than 1. So in this option, which one is lesser than 1? 0.3 is the 1. No need to calculate anything. Directly you can see the formula, see the options and then find the answer. Yeah. So all the conditions are given. Just refer at the last. Now, so in the previous topics, it said that what happens if ammeter is connected in a form of a parallel. If you are connecting the devices in a form of parallel, what will happen to the net resistance? Net resistance will get decreased. So due to the decrease in the net resistance, what will happen means ammeter will get damaged. Why? Because due to short circuit. Due to the short circuit, the ammeter will get damaged. And reason, in parallel combination, the net resistance will get decreased. More amount of current will passes through the circuit. And because of this reason, ammeter will get damaged. Important question. 2 mark or 3 mark, they will be asking this one. So what are the advantages of connecting of electrical device in parallel with a battery instead of connecting them in a series? The first advantage is that we can provide separate switches for each and every device. If it is given like this means which device we need, that alone we can use. So the energy can be saved. This is the first advantage. Second advantage. What is the advantage? If one device is stops working, the other device will continue to work without any issues or without any fault. For example, we are connecting like this. Is it series or parallel? Series. Clear. If this bulb got fused means whether this bulb will glow? No. Reason, the overall circuit has become as a broken. Clear. That means the path has become incomplete. Let's take the second combination. Like this we combine. If one bulb alone got fused, whether the other bulb will glow or not? Yes. That means if one device got fault means the other device will work without any issue. And third one is the net resistance in parallel will get increased or decreased? Decrease. Due to that, the current flow can happen easily. Reason, as per the Ohm's law condition, resistance is inversely proportional to current. In parallel, resistance will get decreased, so current flow can happen easily. And then since all the devices are connected to a common point, in parallel we said that all the devices will be connected to a common point. Since it is connected to a common point, the potential difference in these points is going to remain the same. In our domestic electric circuit, the potential difference is going to be 220 volt. And each and every device will take, since the potential difference is same over here, each and every device will take appropriate amount of current to operate and work. So these are the 4 important advantages of combination in a parallel instead of connecting them in a series. Next, one of the important relation, how to find the number of resistors or number of bulbs need to be connected either in a form of a series or in a form of a parallel. So just remember the formula alone. In order to calculate the number of resistors in series, the formula what you are going to use it is N is equal to V by I into R. This is the formula we'll be using in order to calculate the number of resistors in series. So how we obtain this one? So for resistance, we are going to substitute as N into R. This value we are going to substitute in the Ohm's law. So if you are substituting like this means V is equal to I into N into R. So if you are going to find N value means N is equal to V by I into R. Next come over here. If it is parallel means the final formula what you are going to use over here for R, it is R is equal to R by N. This value if you are substituting, V is equal to I into R by N. If I am going to find N means N is equal to I into R by. Yeah. So what is the final formula over here? N is equal to I into R by V. Here N stands for the number. I stands for current. R stands for resistance. And V stands for potential difference. Next up. Look at the circuit. Is it series or parallel? Parallel. So parallel means is it whether the current will remain same or else it will vary? It will vary. So the first, what are the questions they are asking us to calculate? Current through each resistor we need to find. First, let us calculate the individual current. I1 is equal to V1 by R1. I2 is equal to V2 by R2. I3 is equal to V3 by what is the value of V1? Sir, V 6 volts. Yeah. In the diagram, it's given as 6 volt. In the question, it's given as 12 volt. Let's change into 12 volt. Okay. So, what is the value of V? 12. Why? What is the value of R1? 5. So, we're dividing these two numbers. 2.4 ampere. How much amount of current is going to pass? 2.4 ampere. Next up, V 12 by what is the value of R2? 10. 2 by 10, 1.2 ampere. 1.2 ampere. Next, I3, 12 by 30. Simplify. 4 3s are 12, 10 3s are 30. 4 by 10, 0.4 ampere. So, we calculated the individual current. Next, what we need to find means we need to find the total current. Total current means we can add I is equal to I1 plus I2 plus I3. So I is equal to I1. What is the value of I1? 1.4 plus 1.2 plus 0.4. We're adding all the numbers. We'll be getting us 3.8 and 4. 4.0 or 4 ampere, both are same. Can check whether we made any error. Better. Okay. Next, we need to find the total resistance. So, what is the formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, 1 by Rp is equal to 1 by, what is the value of R1? 5 plus 10 plus 1 by 30. While deriving the derivation, we use the same value. What is the answer? Final answer we got. Rp is equal to 3. Yeah, the same value is there for just refer the derivation.